Hello and welcome to the seventh episode of Daryl Show Your Work. In this episode, we will be covering web application attacks. I'll be simulating some of those attacks for you. So this includes a variety of different versions of cross-site scripting attacks, SQL injections, directory transversals, and file inclusion attacks. So as a disclaimer, this is all for ethical purposes. So none of this is meant to encourage any sort of malicious behavior. So if any of that happens, I'm not going to be held responsible for it. But this is to show how this is just to basically to show how these type of attacks work. And again, it's supposed to be more for awareness purposes than encouraging bad behavior. So, with that said, as you can see, I'm already in my browser within my Kali Linux operating system. So, first thing I'm going to do, I'm going to navigate to our mock site that I'll be using during this lab. All right, so I'm going to just navigate just directly to the IP address instead of just putting the actual website name. All right, so now I'm going to put in my credentials here and log in. All right. All right, so I don't want to save. Okay, so the first thing that I'm going to be covering is cross-site scripting attacks. And the first type that I'm going to cover here is reflected cross-site scripting attacks. So this exploit, this exploits data received in an HTTP request and reflects it in the user's browser. So essentially how this works is that the attacker tricks the victim into clicking a link, usually like via email or some other sort of phishing method. The victim clicks said link, which sends the request to a vulnerable website. The malicious script executes when the vulnerable site is visited. The consequences of that can range from the attacker performing actions in the application using the victim's identity, accessing and modifying the victim's information, and even interact with other users of the application. Again, masquerading as the victim's online or digital identity. So to get started on seeing what a reflected cross-site scripting attack looks like, I'm going to click here, cross-site scripting um, attack, and then I'm going to go to reflected. All right. So once I am here, I am going to enter in some HTML. And this may seem real benign or real innocent, but I'm going to show you why it may not be. So the reason why I'm entering in this HTML code, because what I'm doing is I'm testing this application's vulnerability to basically to web code. So if I can execute any sort of web code here from this input box, then that tells me as a potential malicious actor that I can run code in this box and I could do some damage here from your website by putting in my malicious code into this input box to do some things that I wanted to do. And so I'm going to hit enter here. Well, hold on. I got to put in. So I'm going to write this test here for last name, and I'm going to hit go. All right. So as you can see, the it comes back with welcome cross-site scripting attack test. So basically, those tags were bold tags, HTML tags, and they did exactly what they're supposed to do. They're supposed to bold what I put in the first name text box, which was XSS attack. So it shows that indeed web code does work or does execute when we put it into this its input box. So now let's write something a bit more complex. So now I'm going to enter in some JavaScript code. So I'm gonna say script. Then I'm gonna say alert. I want to give me an alert. Then let's see. Now let's see. And I want it to say reflect to cross-site script. All right. And then I'm gonna, like I did last time, I'm gonna put test here. All right. So now let's run this. Let's run this code and let's see what happens. Hit go. Now there you go. So that alert box came up, and it showed me the message that I wanted it to say. Reflect cross-site scripting. So the problem with this is, let's say that I put some code in and I want it to reflect a certain thing back to me. Let's say that I wanted to vandalize your site and I wanted to put up a nasty message when people come in. Well, I could do that here by putting code into your input box. So I can come to your website, vandalize it, deface it using a reflected cross-site scripting attack here. Or I can have it to return back some personal information to me from this input box. All right, so the solution of how to prevent a cross-site reflected cross-site scripting attacks in specific is to encode user input before displaying it on the page. All right, so the next thing we're going to cover here is stored cross-site scripting attack, and this is more of your persistent version of this type of attack. So I'm going to go here to the stored blog section. All right, and this is where an attacker has managed to store malicious scripts onto the target's web server. These scripts will execute every time a user makes a request to the website. So the way this works is the attack includes a link in the comments section that will be clicked and hijacks the user's account or collects users' data. So I'm going to show you what I'm talking about. So the first thing I'm going to do, I'm going to test this again, but this time I'm going to start out with just a basic bold HTML tags that I did last time, just to kind of show you how this comment thing works. And this could be like, just like an internet forum or article on a random web page or something, and that has a comment section. So I'm gonna hit enter. I'm gonna hit submit. All right, so you see that my comment here is down here, and again, it shows that this type of attack or this type of code, it does execute because it did exactly what I wanted to do. It bolded my message here, which was cross-site scripting attack. So now I know that indeed that I can run and execute code from this input box. So let's run something a bit more shady here. So let's see. I'm going to tell it to okay, yeah, let's do that. All right, so I'm gonna say all right, and then all right, so this is how I start writing my hyperlink that I want people to go to when they enter the comment section of this page. W dot not secure .com. All right, And then I want it to read. I don't want it to actually say that, but I want it to read, click here. Then I'm going to part of my lab here. All right. So, so what you're saying here, attackers often craft the links to look like something harmless in order to trick the users into clicking them. So that's basically what I'm going to show you right here. I'm going to hit submit. So all you see here is a little message here. All it says is click here. So I'm gonna open this up in another tab. And so of course I didn't make anything nefarious or didn't have any type of, send someone to a fake site or whatever. But sometimes you may even get this. You may go here and nothing may happen. But what may have actually happened on the back end is that said malicious actor may have gathered some of your information, or may have done a drive-by download, which is a type of malicious software that runs in the background upon you entering a site. So there's all sorts of bad things that could be done here, but it's just probably good practice or good common sense just not to click on a random link in a comment section that says click here, because it's probably nothing good. But that's just me explaining to you how a stored cross-site scripting attacks works. All right, so now we're going to move on to a bit more complex version of this attack, which is called the DOM based cross-site scripting attack. And this attack, it modifies the client-side code by altering the DOM environment. Unlike the other types of cross-site scripting attacks, which are stored and reflected, um, where the malicious code inputs originate from the server, DOM-based cross-site scripting is generated client-side through JavaScript. So DOM, which is short for Document Object Model, is a programming API that represents how the browser renders HTML and XML documents. It defines the logical structure of a document and allows languages like JavaScript to manipulate the HTML elements. So I know this may sound really really technical, me saying that, but I'm going to show you what this looks like, and you may have a better idea. So I'm going to go to the part of the website here that's for the cross-site scripting DOM attack. All right, so first thing I'm going to do when I get here, all right, I'm going to enter in some credentials. See if I can remember what I set them to. Okay, so type Dom is the first name, and then we're going to type test as the last name. All right, and I'm gonna hit go. All right, so there's two things that I want you to pay attention to. So down here, I got my message like we've been getting. So my first and last name that I put in. So my first name Dom, last name Test. However, look at my URL right here. So as you can see, it's telling me that my first name is equal to Dom and my last name is equal to Test. So this is the part of the client side information that's pulling from that I was referring to. So so hold on, let me back up here, because there is one thing I actually forgot to explain to you. Is that the way that these DOM attacks work, they occur by you have to first identify the DOM source and the DOM sink. So the DOM source is oftentimes the user controlled data source that the web application passes to a function. So think of that DOM source as that first and last name. So DOM first name, last name Test, Those are the DOM sources. Now the DOM sync is a function that that takes the data from the source to modify the HTML layout, which enables the cross-site scripting attack. So to show you that, I'm gonna go to page source because so we've identified what the DOM source is. So let's identify what the DOM sync is, which is the function that is passed to. Okay, hold on. Let's try that again. I might click the wrong spot. Yeah, I had that highlighted. Okay, page source. All right, so I'm going to scroll all the way down here. I believe it is line 214. All right, so looking at line 214, so we can see where the variables have been set, where Dom first name has been set, last name test has been set. Those variables has been set because those are that's what I passed through. Now the function that is going to is this part right here, this inner HTML, is this part of the this line of code. All right. So I want you to remember that this inner HTML. So I'm gonna exit out of this. All right. So then the next thing I am going to do is enter in a different. I'm going to replace part of this this URL with something else, and to show you how an attacker, once they figure out what the DOM source is and what the DOM sync is, how they can then manipulate the data that's being passed to and from it. So I'm going to replace everything after the IP address with XSS underscore get. And the reason, I'm not sure what happened there. Well, let's start that over. All right, so the reason why is get, because what I was showing you when we went to view page source, I was showing you that's what basically what that was with get command. All right, so we're going to take advantage of that get command, and we're going to put something a bit different there. All right, and then okay, and then we're going to image plus source. All right, then we're going to tell it to give us an alert similar to what we did before in the stored procedure. M right, then greater than 10%. Then we're going to have it within the last name. We're going to put test and form equals submit. All right. So all right. So I'm adding. So I replaced what was what was there before in the URL with a different command. And so when I hit enter, that did not come back the way I wanted to. So this is where syntax is important. All right, so make sure my syntax is all right here. Yeah, let's see. First name. Okay, I missed the beginning of that tag. That's where I screwed that up. All right, let me see. All right, now let's try again. There we go. All right. So it's kind of similar to the reflected attack. It came back with an alert. And again, it's just a different method of doing the same type of thing, except when I was able to go into the page source and to do that inner HTML function was our DOM sync. And I was able to define that once I knew what our DOM source was, which was DOM and then test. So that is an example of a DOM based cross-site scripting attack. So now we're going to move on to an SQL injection. All right, so with SQL injections, it's a web security vulnerability that allows an attacker to inject malicious SQL statements into database queries. It enables unauthorized access to data, such as other users' information. So a lot of applications, in order to return information that you may ask for, they have to connect to databases. Well, if your input is not your input bar, wherever somebody's inputting information, if that's not properly sanitized, then basically someone could come in and just query your database as if they were on the back end for database information and see far more information than they're supposed to see. So an example of that, of how we would test this, is we would first just put an apostrophe. All right, so I'm gonna hit or a single quote. All right, so I'm gonna put that and hit search, and let's see what happens. So I got an error message back. But if you pay attention to what the error message says, the error message list tells me what database type and server that's being used, and that's a Maria DB server. All right, which is not good. You typically don't want your visitors to know what type of technology, back-end technology you're using, especially if you're talking about malicious actors, because then they can find a specific vulnerability, they can find particular exploits that database type may be vulnerable to, and start getting start causing a data breach, getting information that they're not supposed to have access to. So another way that we could get even more information. So once we find out that works, another simple command that we can run is a single quote space or and 1 = 1 dash single quote. All right. And so because 1 = 1 is always true, the query is going to return all the entries in the table associated with this page. So let's see if that works. When I put that in, we know we can access the database. See, and now instead of just giving me a couple of names of things that I wanted, now it gave me everything in that database. And again, the problem was that whoever developed this website, just speaking just in theory, they did not do proper input validation, meaning they didn't stop the allowance of single quotes or equal signs or greater than signs, because these are typically special characters that are used in code and especially executable code. All right, so the way that this could have been prevented is the developers or the website designers and developers, they could have tested a SQL injection or cross-site scripting vulnerabilities before putting the web application in production. Again, like I just said, this includes input sanitation techniques such as escaping special characters. This stops malicious queries that can cause unwanted behavior from being asserted. From being asserted. All right. So the next web attack we're going to cover is directory transversal, and we're going to start with directory transversal files. All right, so the first thing we're going to look at with this web page is not necessarily what's here, but again, we're going to be paying attention to the URL. So by looking at this, we can tell that this web application is pulling from a file in the back end called message.txt to give us this display on our website. So just to break down what directory transversal is before I get into going into how it can be exploited. It's a web security vulnerability that allows an attacker to access restricted directories on a server. These directories may include sensitive files such as application code, credentials for backend systems, or operating system files. So how this works. A traversal attack occurs when an attacker bypasses access control lists and escapes the root directory. This gives access to sensitive files outside of the web server's intended scope. So again, it would allow us to, if we were to manipulate and play with this URL, once we able to find out that it is vulnerable to this type of attack, we can start to kind of travel a bit into the backend web server and look at the files that are on there, and be able to try to find out what type of technology you're using, or even personal information of other users that access your site, especially if it's an e-commerce site. So in order to test this, first thing we're going to do, let's assume we're going to test to see if our web server is running a Linux operating system. And the way we do this is we're going to try to access the XE password directory, which is a common directory in Linux boxes. All right, so all I did was replace message.txt with XE password. All right, so I'm going to hit enter and let's see what it gives us back. And we can see all the usual type of files that we would typically find in an XE password directory within a Linux OS, which is not good. All right, so that lets me know as an attacker that, oh, then I can just start typing in all type of common directories here, and start to try to pivot throughout your web server here, and to try to find any other type of critical information that I could find, again, like the personal information or password hashes of users to then dump and then try to crack using like a rainbow table or any other type of a hash cracking software, which I haven't got to yet. We did discuss hashes during our last video, but this would be a means of how a malicious user could get into a network or get into at least a web server from an external facing website. So if we wanted to see with this, not just viewing files, but we just wanted to try to do this with the directory themselves. Another thing we can do, let's see if we wanted to, let's say, change this again, but let's say we wanted to um, pivot into another directory. So let's say I want to know what else you're hiding here in your in your um in your web server. So I'm gonna try to move up a few directories here. So I'm gonna say // Every time I do that, that's me moving up another folder in the directory. So I'm gonna do this 4 times and let's see where it gets me. And so where it got me is now I'm getting a list of all the directories. So I could just simply click into here and see the contents of these directories. So let's say I wanted to go into media, for example. I just click there. And of course, nothing's found there. But if there was something there, I would be able to see it because I now have access to it because I was able to play with the command line and reach it from there. All right, so those are some examples of directory transversal. And lastly, the last web attack we're going to discuss is file inclusion. That can either be done remotely or locally. So this occurs when unvalidated input are passed to server-side functions that access files. An attacker can modify the file name in an HTTP request to include malicious scripts. Depending on the script, the attacker may be able to execute code on the server, perform cross-site scripting attacks, cause a denial of service, manipulate data, and or access sensitive information. The local file inclusion, the local version of this, allows attackers to include files that exist locally on the server. All right, so one thing, let me see, make sure I'm at the, okay, so the first thing we're going to do is we're going to choose a language. All right, so we're going to start with English, okay? All right, so I'm going to hit go. All right, so again, the thing we want to pay attention to is up here at the top. You see, after language, it tells us we have a lang underscore en.php file. And so clearly this is how it's pulling which language to display here, depending on what option did I choose. So in order to test that theory, we're going to try again and see if we get a different language code after language. Let's see. Let's hit go again. And as I suspected, so after language, we have lang underscore fr.php, clearly for French, because we chose French this time, and then we got French output. So what we could do something similar to what we did with the directory transversal, except we're gonna do file inclusion here. So we're going to use the where the URL will pull from the file to give us a certain type of output. We're going to try to use this as a way to access the password directory again. All right, and then I'm gonna tell it to go as if we actually wrote in to go. All right. I mean, I'm sorry, like we actually clicked the go, but we wrote it in. So I'm gonna hit enter and see what happens. And similar to the directory transversal attack, the output, instead of giving me a language, it gives me a listing of everything within that XC password directory. So again, this would be dangerous if then, let's say I would go to your shadow file, which lists your which lists all the password hashes for any user that's associated with that web server, or any user of this site with it, which that web server's database may be holding. I can put in the directory that houses that, get the hashes as an output, and again start building a rainbow table to try to crack those hashes to get the clear text passwords, then to go in and log in as those users. All right. So in this case, the include bracket function copies the context of the contents of the exe password file and displays it on the website, just like I explained. So that's pretty much it for web-based attacks. The main thing to take away from this, if you're building a website, if you're a developer or designer, to make sure you test you properly test your input areas of your web applications before putting it into production. Make sure that that you sanitize it, and that it does not escape any special characters like your like a greater than, or your equals, or your single quotes. And as I explained with some of my past videos, uh, some of the steps I took, I have not been able to post some of the commands because, well, YouTube actually has great input validation or sanitation, where it doesn't allow the characters that I just mentioned. And so then I have to usually like write them out, or try some other way to kind of let you know what to the commands that I wrote, in case you may have missed it in the video. But that's going to end it for this episode. Again, do all the great stuff like, share, subscribe, and most importantly, to show your work. And